Hello, I'm Untitled, and I'm glad to welcome you at the first video in the Explaining Rust Analyzer series. So, Rust Analyzer is a language setup for the Rust programming language. I'm one of the original authors of Rust Analyzer, and in this series, I would like to explain you how Rust Analyzer works under the hood. The idea is that we will be recording short videos for about half an hour, describing each specific interesting subsystem or area of Rust Analyzer. This video, the first one, would actually be an exception. Here, I would like to take a broad overview of the Rust Analyzer project and give you a set of entry points of how to look at this project, how to work with it, how to build it, how to use it. So, let's get started. I think the first thing you should start with if you want to contribute to Rust Analyzer or even learn how it works is the Rust Analyzer website. Rust Analyzer website has this gigantic manual. It's like actually a problem that it's like too big. There is an open issue to make it smaller and more user-friendly. But if you really want to understand how things work under the hood, then the big manual is actually a big advantage. So this manual lists various installation options, which are probably not very interesting. It also has this troubleshooting section. And the troubleshooting section is especially useful when you want to understand why something doesn't work the way you like. Basically, if you are facing some kind of an issue, if you're having some kind of a bug with Rust Analyzer, usually you start with troubleshooting and then you kind of like narrow down what is the problem, and then you dive into the source code, fix it, and send pull request. And every other user of Rust Analyzer rejoices. Okay, so troubleshooting is one thing you should look at the manual. Another thing is that we have a ton of features here. Basically, everything which Rust Analyzer can do is documented here. And if you click on the feature, such as type and assist, you will see that each feature has this source subsection. And this actually links to the source code of this feature. So one way to dive into the code base is to find a specific issue in the manual, then look at the source and go from there. Okay, so let's finally go to the source code. I will go to the project directory. I will update it to the latest master branch. And what I typically do after cloning Rust Analyzer repository and starting to work on it is I will rebuild it from source and install this development version of Rust Analyzer into my VS Code instance. So there is a handy command here, spelled cargo xtask install, which installs Rust Analyzer. So let's run it. And while it is running, I will explain a bit what this does. So this will actually do two things. First, it will install a binary of Rust Analyzer built from source, and then it will install the VS Code extension into current instance of VS Code. You might notice that I'm passing jmalloc flag here. It's just that I want to use jmalloc as an allocator. To be fair, personally I don't perceive big difference between different allocators when you use Rust Analyzer, although the difference is visible in the benchmarks. So jmalloc here is more like just my odd habit and not something which is required. This one will be enough. Okay, so now once we have Rust Analyzer installed, let's look at the actual source code. One thing you will notice is there is like actually kind of like not extremely large, but a pretty big amount of source code in Rust Analyzer. I'm actually curious what's size of it, it's not okay. Yep. So it is about, well, it's almost 200,000 lines of Rust code, which is, yeah, medium sized. Okay, so here is the source code. What are the interesting things here? As usual, the first interesting thing is README, which contains all various bits of information. The most important one here is probably this link to the Zulip stream where we discuss various things. So feel free to join this Zulip stream if you want to ask any questions about Rust Analyzer or just want to follow the development. Note that we also have our weekly meetings on the Zulip. Although weekly meetings are usually pretty quiet, we try to communicate asynchronously. And we also, like every 6 weeks, while Rust is having release, we are having a so-called steering meeting where we decide about like overall direction of the project for the next 6 weeks. So steering meetings are especially interesting streams on Zulip you might want to follow. Okay, so the next interesting folder in Rust Analyzer is the docs folder. It is organized into two subdirectories, documentation for the users and documentation for the developers. We actually saw the documentation for the users earlier today on the website, and here is the source code of the manual. Note that I'm personally a huge fan of ASCII Doctor. Well, I should say ASCII Doc documentation format. I try to use it over Markdown whenever I can, and that's why the manual is formatted in the ASCII Doctor. Another interesting thing about the manual is that a lot of it is generated from the source code. We will probably go into that a little bit later in this lecture. Anyway, so user folder contains user-facing documentation. The dev folder contains the developer-oriented documentation. So README is basically a kitchen sink for everything which doesn't fit any other specific section. You probably want to look at the README first, although you don't want to read it thoroughly, you just like want to glance through it. The document which you do want to study rather carefully if you want to contribute to Rust Analyzer is this architecture MD. I wonder if, well, go to definition works in Markdown. Nice. So yeah, this architecture MD tries to document a high-level architecture of Rust Analyzer, and that plays roughly the same role as this explaining Rust Analyzer series. So they're kind of like complementary. The series will probably be a little bit more in depth. Yeah, I should say it will actually be like significantly more in depth. But like the drawback is that it will be many videos for half an hour, while for Architecture MD you can just like read it in one sitting, like drinking tea, whatever. What else do we have here? The next most important document is style. So in Rust Analyzer, we actually try to be pretty well. We are not very strict about code style and that sort of things. So like, don't worry, you can like submit code in whatever fashion you can. But if it doesn't fit the overall style, it probably will get refactored pretty soon to something which fits the way we code in Rust Analyzer. Obviously, we are using Rust Committee to enforce the basic things like spacing and new lines and that sort of stuff. And here we discuss like more philosophical issues, like how do you actually do things. Like, for example, I don't know. Yeah, to give to give an example which we saw in one of the preparationary videos for this series, here is like the rule about how we initialize things. So we use default, we don't use new functions, because new functions are great for libraries, but you usually provide new and default, and then you have a choice about what to do. So in Rustanalyzer, as we are not shipping a library, we don't care about APIs being like nice and beautiful. So we just say, hey, only default, and that removes the unnecessary choice. Another thing is that we try to be very strict about types in Rustanalyzer, so we, like the style guide forbids providing dummy defaults, and really requires that if you have a default, then the type really has some empty value. Anyway, to reiterate, this style guide is advisory. We will actively refactor existing code to follow with style guide. And the style guide is the tiebreaker when you have two different ways to write any particular code. But you can send pull requests in whatever style you want. As long as pull request actually passes all the tests, then it's fine. We will be fine merging it and cleaning up if necessary later. So yeah, style guide. Actually, I really like the style guide. I like that when I review pull requests, I can actually send links to this document. That way I try to make the culture of the code in Rustanalyzer more transferable so that it's not just like in my head. Okay, so let's see what else do we have here. There is like a document which describes how to debug Rustanalyzer itself with debugging. I must say I don't personally use debuggers in Rust. I do use debuggers heavily in Java because debuggers in Java are just awesome. But in Rust, I don't feel very productive with LLDB or GDB style debugger, so I just debug with prints, and I can't really say if this like works today. It probably does. The other documents here are like guide and syntax. They describe in some more detail some specific aspects of Rustanalyzer, but these documents are very dated. In fact, because they are very dated, I want to record this video which kind of like refreshes this stuff up. Okay, so yeah, docs are your friends. What else do we have here? Okay, we have this interesting xtask directory. If you remember, we already see this word xtasks when we installed Rustanalyzer. So this is a cargo hack, which actually I kind of accidentally invented a while ago. And like the documentation for this hack is available in this repository. But I will quickly show what's the idea here. Basically, as you saw, Rustanalyzer install command installs both Rustanalyzer and the VS Code extension. So it cannot be just a plain cargo install. We need to do cargo install and something else. And xtask is basically a way for you to provide custom build logic for your Rust project. It works in a really simple way. There is an xtask ls in the cargo config, and it just asks cargo to run this specific package and this specific binary. So this is the package, and this is the binary. And if you look at how it is implemented, there is this install command, and you can see it has like various options, which you, by the way, can see by invoking -help. -- help. Yeah, sorry, like we try to keep okay, finally it works. We try to keep xtask as lightweight in terms of compile time as possible, because it is the first thing you invoke, so it's important that it compiles fast. So we don't use clap, rather we use this X flags variable, xflags crate for parsing command line arguments, which is like really bare bones and does the necessary minimum, and sometimes even less than the necessary minimum amount of work, but it gives you a nice API and it compiles quickly. Anyway, so we have this install subcommand, and then if we hit install here in the main, we actually run this install subcommand, and this install subcommand will do a lot of shelling out to various things, like we will run cargo to verify that, yeah, you actually can compile Rust Analyzer, and then we will install it, and then we will install the VS Code extension. So as you can see, there is like a whole bunch of things we can do here. Let me quickly go through the command. So install does the installation, fast tests run fast testing, although I must say we actually rarely do run this command, and there are a couple of outstanding fast testing failures which we are not fixing. Basically, today Rust Analyzer is in a phase where we try to cover basic functionality. We don't shoot for maximal reliability just yet. And that's why we kind of have a bunch of known test failures, and we think that they don't actually affect users in practice, so we are not fixing them just yet. Although if you are really irritated by this and want Rust Analyzer to be really reliable, fixes are very, very welcome. And indeed, establishing proper fuzzing for all subsystems of Rust Analyzer is a long-term goal. But yes, today we are in the phase where we try to make something work rather than trying to make everything work correctly. Other subcommands. The release subcommand prepares a release of Rust Analyzer, the one you see every Monday on Reddit. It pushes a special branch to the GitHub where it is picked up by our test automation and then published to the GitHub releases as a binary, and also published to the and the extension is published to the marketplace, VS Code marketplace. The promote command moves Rust Analyzer, like updates the Rust Analyzer submodule in the Rustlang repository, and the dist command is a helper command which is used by release and promote, no, only by release, to actually produce the production binaries of Rust Analyzer. If you look at the dist command here, you, for example, see that when we're building a dist version of Rust Analyzer, we actually use LTO. Although by default, we don't enable LTO for our release profile, because that makes things actually slower. We also enable incremental for our release. And that makes me wonder if actually we should disable incremental in our dist. We probably should. It probably might also be disabled due to the way our CI is set up. Anyway, we will look in CI later today. So yeah, that's the dist subcommand. And there is also metrics command. It produces let's go to the source. The metrics subcommand produces these beautiful graphs which are built on every commit, where we can see how our build time looks, and it seems like we are getting slightly slower to build, which is unfortunate. What the memory usage looks like, and you see we recently improved memory usage a lot, and of course there is like correctness metrics about type mismatches. Again, you can see that we improving the feature parity of our type checker. And yeah, we run these metrics for ourselves, like the self is the Rust Analyzer code base itself. And we also for like a bunch of selected other code bases, such as Diesel and RevGrab. Okay, and that's like a very funny BB subcommand. So this is build benchmark or something. I don't remember. Basically, like it's BB because it is short. When I optimize Rust Analyzer, I always want to compare like two different versions of it, like baseline and the version with some optimizations. And what this subcommand does is that it builds a specific version of Rust Analyzer and puts it directly in the target. So not in the target release, but in target and with like some specific suffix so that I can easily look at. I wonder if I can show it. Yeah, so when I do cargo xtask bb baseline, it will provide this binary. And then I can like make it fast and do this, and then I will get like Rust Analyzer dash fast, and then I can hyperfine Rust Analyzer baseline versus Rust Analyzer fast. While we are talking about metrics and benchmarks, it also probably makes sense to mention these Qt subcommand, analysis stats. So analysis stats is an internal subcommand, and it is sort of a batch mode of Rust Analyzer. What it does, it causes Rust Analyzer to load the current cargo project and then to type check every function in the workspace. And this gives you the rough idea about Rust Analyzer performance for batch tasks. So it isn't what we necessarily optimize in the IDE, because in the IDE you really want low latency rather than high throughput. Well, ideally you want both, but your primary metric is latency. And the analysis stats is strictly throughput-oriented benchmark, but still it is useful, and it is especially useful when you want to optimize memory usage. Okay, so that's it about xtasks. What else we have here? I guess we have assets with logos. I don't remember that. We have benchmark data, because sometimes you need to feed artificial data to Rust Analyzer to make some fast benchmarks, not integrated benchmarks. One interesting case here is like the glorious old parser. I believe this is probably the longest non-generated Rust file ever written. This is the parser from the Rust C compiler before it was split into separate files. As you see, it is 8,500 lines of code, and it's kind of like a good benchmark for Rust parsers because it's like pretty big. And yeah, this one, it's just like some pile of rather complicated macro rules to stress test our macro expansion. The problem with testing macro expansion is that you really want to handwrite big macro rules yourself, because it's hard to generate. Well, it's not necessarily really hard to generate random macro rules, but we haven't figured that out yet. Anyway, let's close this. It looks intimidating. Yeah, that's much more friendly. So what else we have here? We have the editors folder. The idea is that the original idea was that we would like to maintain like first-class plugin for each editor in source in this repository, but it's and originally we maintained the VS Code plugin and Emacs plugin, but then Emacs plugin got merged into Lsp mode and it is maintained upstream. So today we only have VS Code extension here, and we actually are thinking about moving it to another repository, because today VS Code extension does not change that frequently, so we don't necessarily need it to keep in this repository. And keeping it here causes problems, because we need to care about npm build, Node.js, and all that kind of stuff, and I don't know. Maybe I am just unlucky, but for me it breaks pretty frequently. While I was discussing this, I actually realized that there was a rather interesting document in the dev folder which we forgot to discuss. That document is called Lsp Extensions. So the idea behind Lsp is that you have like many editors, many languages, and you want to have a common protocol. That's nice in theory, but in practice that means you kind of have only like the lowest common denominator between things, and to provide a really great user experience, you kind of like really want to push beyond this boundary. So Rust Analyzer provides a whole bunch of custom extensions. We try to work with the upstream to actually move these extensions to the official protocol, but that's like not really easy and not really fast, so we usually just don't care and focus primarily on our own extensions and then let upstream to accommodate them at their own leisure. So everything is every extension we use is documented here, and other editors can try to use those extensions, and also other languages can also try to use these extensions. So kind of like the goal here is twofold. The first is to make sure that developers of Rust Analyzer extensions for various editors can easily implement custom features. And the second goal here is to standardize some common extensions between languages. I'm not sure if any languages actually use some of Rust Analyzer's extensions today, but for example, Rust Analyzer does use an extension which originally originated in ClangD. And to give you like a good example of like why do you want to have custom extensions, let's look at the Runnable Extensions. So this is like one of my favoriteest features in Rust Analyzer. Where are the tests? Yep. So if you place a cursor on a test, so you see this is a test and the cursor is inside it, there is Rust Analyzer run action, and this action allows you to run this single specific test. This is really invaluable when you want to fix some specific bugs, because you run this test and only this, and you immediately get feedback about if it works or not. And then you can try to... Okay, so sadly we need to wait some time until the thing compiled. Seems like I haven't compiled Rust Analyzer in debug mode for quite some time. Yeah. So I've said that it will run one test, and it did run many tests. Okay, yeah. So I was testing the whole module. So yes, you see only one test was run, and which is helpful because, for example, if you try to hack on something and yeah, let's just try to break something, you can quickly get feedback, well, as quickly as Rust compiles, about your edits to the source code. So yeah, use this extension. And this isn't actually available in VS Code. VS Code has tasks, but tasks do not have the notion of a current cursor position. VS Code does not allow you to get a list of tasks which make sense in this specific context. And that's like the core of this extension. It allows you to look at the specific cursor position and then provide the list of tasks which make sense here. And if you see here, there would be runnables, which is documented here. And then there is Lsp Ext.rs, which defines the Rust Analyzer side of these runnables. And then there is Lsp Ext.ts, which describes the TypeScript side of these runnables. So that means that for each extension you have 3 parts of the code base which touch it. The Lsp Extensions Markdown, which documents it, the Lsp Ext.rs, and Lsp Ext.ts, which implements server-side and client-side part of the extension. Okay, so let's continue with our overview. Yeah, I guess we covered all of the auxiliary stuff, and now it's time to look at the actual code. First, there is a lib directory. The idea behind lib directory is that here are the crates which are independent of Rationalizer and published to crates.io, but we maintain them in this repository just because it's more convenient. Today we have only one such crate. I guess if we had the libdir historically, it would also contain things like Lsp server crate or text size crate, but we didn't have it initially, and once we had it, turned out that only one crate needed graduation to it. So yeah, the crate here is arena. It's just one specific way to implement arenas. There's like 1 million arena crates on crates.io, and this is mine. This is the one I like best. And finally, where all the real source code lives, is the crates directory. One thing to note about it is that it is flat. Rationalizer is a workspace. It has many crates, but all the crates have this like rather flat structure because we don't have too many crates. They all fit in a single screen, so I don't see a reason to make this structure nested. At the same time, there is some high order structure here. You can see that several crates have common prefixes like IDE here and like proc macro. So let me try to explain the broad organization here. The main crate, the entry point is Rationalizer. This is the crate which contains the main function, and if you want to understand like Rationalizer thoroughly, started this main function and just read everything. The goal of Rationalizer crate is actually to basically provide Lsp. So probably the better name here would actually be just Lsp. I wonder if we should rename it to that. Yeah, because like currently it's like name Rationalizer just because we want to have the final binary be named Rationalizer, but really it's like semantically it's language server protocol support. So this doesn't have any logic about Rust. It has mostly code to convert from JSON messages to internal Rationalizer data structures and back. The next layer is the IDE crate. The IDE crate is the primary facade of Rationalizer. It defines this like analysis stats, and this is where you get like completions and go to definition, go to declaration, and all that stuff. So this is like the actual API of building an IDE for the Rust language. Internally, we split IDE into several crates: completions, diagnostics, assists, because, well, there is a lot of functionality in Rationalizer, and it's just like faster to compile if, for example, all of the assists are in a separate crate. And as you see, there's like a lot of code in some of those crates. So yeah, IDE is for IDE stuff. To do IDE stuff, you need to have a deep understanding of the language. You need to basically compile it. You need to resolve names, you need to compute types, and all the other stuff. And that what is handled by here crates. Here crates are the implementation of the compiler. And again, if the IDE was a facade for IDE functionality, then here crate is a facade for the compiler functionality. And it defines, while the IDE crates has like this analysis struct, which is like the single entry point for the whole API, and the API is relatively flat and based on plain old data structures. The here defines like a lot of different types. There's basically a type for anything. There's like a type of function, a type. Where is a function? Yes, a type for a function, a type for a module, a type for a type alias, and as you see, these things actually don't hold anything. They hold just IDs, and we will talk about how the data are actually stored in the database, in the salsa, in some of the later lectures. Anyway, like IDE, HAR, Rationalizer as like a main entry point, and a whole bunch of other crates. I wonder if there is crates I need to specifically tell about. So flight check. Flight check is interesting. Today we cannot produce reliable diagnostics from within Rust Analyzer. We have to run cargo check and reply cargo check diagnostics at you. Flight check is what implements this, and the name is shamelessly stolen from the module of Emacs, which I used before I started building IDEs. Proc macro API, proc macro SRV, and proc macro tests are there because proc macros are terrible. So proc macros can run arbitrary Rust code, and it generally is a bad idea to run arbitrary Rust code in an IDE because it can freeze IDE, it can crash IDE, it can do whatever. So we have this elaborate system where we spawn a several process which actually runs proc macros, and we communicate with that process via RPC. So this family of crates deals with that. MBE, macro by example, is a crate which deals with macro expansion of macro rules macro, so it's somewhat less scary than proc macros. Project model is a crate which deals with loading cargo model, cargo tomls into internal Rust Analyzer representation. What else? Profile. Profile is actually really interesting. Again, it needs really a whole separate lecture, but basically it provides internal profile infrastructure we use in Rust Analyzer. TT is a part of macro by example. VFS is our implementation of virtual file system. I don't want to go into details about that. Those are like various smaller helper crates. I guess in this lecture I want to discuss STDX a little bit. So STDX is Extensions Started Library. It is a crate which doesn't have any other dependencies, and which is dependent on by any other crate in Rust Analyzer. Here we put stuff which isn't stabilized or even submitted yet. For example, here is this equal range by function, which is, well, stolen from C++. It takes a sorted slice and runs a binary search to find a range of elements which are equal to the given key. And I wanted to submit it as a pull request to Rust repository for like half a year already, and I don't have time for that. So if you're watching this video and you want to contribute to Rust, please submit the equal range function to the Rust line. But be careful in that it needs like 3 different versions with like by key, by function, and like by value, and it needs documentation. So it's like slightly more involved than just like copy pasting that code, this code into Rust Analyzer repository. Rust lang Rust C repository. So yeah, a bunch of extensions. Another interesting crate is SourceGen. Again, I don't think we have time to dive deeper into it just yet. But the idea Rust Analyzer is that we do a lot of code generation. We actually saw some of that already today, because you see in the manual, it actually consists of like many separate files. So there is like includes, yeah, there are ASCII doctor level includes here, and generated config means that this is actually generated, and this file indeed is generated from source from this configuration data. Similarly, there is generated features. Yeah, generated features, where we see, for example, run feature we looked at previously, and this is generated from the doc comments in the source code. And this is how you get links to the source code in the manual. So when we generate this, we kind of like, yeah, put the link in here. And the infrastructure for doing this kind of like source generation is built in this source gen crate, which like isn't really big, isn't really smart, but really helps to save a lot of work in Rust Analyzer in the long term. And there is, for example, source gen features. Yeah, source gen feature docs is the test which will regenerate that documentation. Okay, I guess this covers most of the overview of Rust Analyzer, like how the repository organized and how the source code works and how you can actually install it via cargo xtask install or run in batch mode via analysis stats. So it probably is a good place to call it a day and finish this video lecture. Thank you for watching it, and see you next time when we will be discussing something else. I haven't actually decided what will be the topic of the next lecture. Either we will go from the bottom up and we will look at the syntax trees, or we will go top down and look at the VFS and Rust Analyzer's event loop. Anyway, that's for the next lecture. Thank you for watching. Goodbye.